So we're going to start lab 13 now. First of all, we're going to start the non-inverting op-amp analysis. This is all theory, so what we worked in class, go through, calculate voltage gain, calculate what the output voltage should be if you have this input voltage, calculate the voltage and current through each resistor, and record those. Don't move on and start doing the lab till you've done this pre-lab part. When you're ready to construct it, come over here. Here's our schematic. I want you to note a few things. We don't actually have a full schematic that shows us an input source or shows us an output where the output is going. It also does not show us the power supply for this. We're starting to get to the point where our schematics will assume that you understand how to build a power supply, or to connect that you have to, they'll assume that you understand you have to have a power supply in order to make a circuit work. So they don't show it, just assuming, well, you'll know better. First thing I got to look for is this op-amp is a 741 op-amp, the most common op-amp out there. I look up its pinout. So this is what the pinout looks like for a DIP, D-I-P, dual, two sides, inline pins. IC, it's an integrated circuit. So it'd be a DIP form factor, and it's an IC, an integrated circuit. Inside will be about 20 transistors that build this op-amp and build the connections for it. It's a standard package. This one's 8 pins. The pins are listed 1, 2, 3, 4, 5, 6, 7, 8. And we read them. Pin 1's an offset null. We won't end up using that. Pins 2 and 3 are the inverting input and non-inverting input. Of note, inverting input, non-inverting input. Those are not plus and minus voltage. Do not plug the voltage from the rails into those. Where our power supply comes in is number 4, which shows minus V. That's where we connect the negative voltage to. 5, offset null. Again, we won't be using it here. Output is 6, so that's where we'll measure our output. Plus V is where the positive supply comes in. It's really important I get the positive and negative supplies there. If I don't do those correctly, my chip will probably get hot and then it will stop working. So it's really important I get power first. 8 is NC. That means no connection. Okay, so the first thing I want to do is get positive and negative power supply. So one of the things that's happening now is I have a positive and negative to power the op-amp. There is a ground down here, and ground is not negative. Do not connect negative to ground. Do not connect negative to ground. That's the same thing as connecting positive to ground. Okay, ground is a 0 point. It's a bit like if I pick this as 0, I go this direction so far, that's in the positive direction. I go that direction so far, it's in the negative direction. You could just as easily label this as where I'm currently standing, and I went so far east, or I went so far west on standard map. So they're just directions. So I go down and look at my supply. I have positive, we've used all semester, and ground. I've already got those connected from previous labs. For the first time, I'm going to use the negative voltage. So I'll come in and I'll connect my wire to the negative. And I'm going to connect it down on the bottom because I'll need it there, but I'm going to make sure it's not the same as ground. So ground I have down the one with the red, has a label plus out on the end. Again, that doesn't really mean anything, it's just for me. And I'll put this in the blue one. I could put them side by side just to be a little safer. I'll stagger them a little bit just so it's less likely I accidentally get 2 wires touching. Now I'm going to turn this on, and I'm going to go ahead and set up my supplies. I'm supposed to go plus 15. So let me put this up where you can see it. And there we go. So I'm at plus 12. What I'll probably do now is just turn this up a little bit, and what I'm actually going to do is just put a little wire in my ground so I can just clip on it. This is just to make it easier. If I had the ones with the just long straight connectors, I could just slip them down in there and get this. But now I got hand free, and Apparently not getting any ground. Oh. This wire must be too short. And it's not connecting to my ground. So rather than going on, I will quickly clear that up. Now we'll try it. Hopefully we're at 15 now. There we go. Well, we're 12. We got to turn it up to 15. So we'll go up to 15. Now I want to set this to minus 15. So this is compared to ground. I want to go down where it shows minus 15. So minus 15 compared to ground, 15. That does mean if I look at these two compared to each other, that's 30 volts difference. So that's what will be going to my op amp. Now I'm going to go ahead and turn off power while I wire the rest of it up. If I return to my pin out, I want to look for pin number 1. So the way I look for this is there will either be a notch on one end. This particular IC doesn't have it, but it'll be a little half moon notch. It doesn't go all the way through. It's just on the very top plastic part. Or there'll be a little circle right next to pin 1, which is what this has. Some even have both. Also, I want to read on top. You probably can't read it because of the lighting with the camera, but it says 741. There's a letter afterwards, but it's my 741 op amp. They're designed to go in and straddle this little trough. That's why that's there. I mean, it separates the two sides, but it's also the perfect size. Make sure if you have a rough spot somewhere on here, make sure you avoid it. All right, now, actually, after I put this down, I'm going to very carefully move it more towards the middle, and that's only to make one of the later setups a little easier for wires I already have cut. Okay, now I'm going to go ahead and get positive and ground. I'm sorry, positive and negative. So negative goes to 4. So I will go to 4, and I will go down to negative. And if I look on here, 7 is positive. So I'm going to go up to 7 and connect that to positive. This should have power to my chip now. So what I'm actually going to do is I'm going to go ahead and turn on power. I'm going to put my finger on that chip and make sure it doesn't get hot. If it starts getting hot, I'll immediately turn power off. Okay. Also notice my chip is turned 90 degrees from the way the picture shows this. That's not uncommon. You just got to be able to move around and adjust your perspective. You can always turn the paper. I mean, seriously, you can just turn the paper some direction. Okay, so I'll go down here and ground, get myself a ground measurement. That's the easiest way with these clip-ons is just to slip a little wire down there. Okay. And then I just want to double check that I'm negative. I'll touch the pin right here just to make sure I get, so I should be at minus 15 volts. I am not at minus 15 volts, and that's concerning. And up here I should be at 15 volts. And that's also concerning. That tells me, I bet I'm still having issues. I think this wire is just not wanting to sink down there, or my ground's not wanting to sink down there. I want it to. So let's try that again. By the way, you'll see me having a little issues, and some of this is, I really intentionally don't go back and redo these because you ought to see how I have to solve them as I go, because that's just part of it. I have to solve them too. And there's no magical solution. You just have to work your way systematically through the different possibilities. Alright, so now I've got power to my chip. R1 is a 10 kilo ohm resistor, and it goes from the output to the inverting input. So I look, pin 6 is the output, the inverting input's pin 2. One thing that might be worth doing is going up on this chip and writing pin 2, pin 3, pin 6 on here so you have them labeled. Also, do note on the op amp, whichever input's on top is completely arbitrary. So you may end up with the inverting, sometimes non-inverting, top bottom. You might end up with them flipped over like this. It's completely on however the schematic is easiest to draw. So I want to find, what do we say, R1's a 10K. So I have one sitting here. I want to take it from the output to the inverting input. So the inverting input again is pin number 2. I'll just take it there, and output is pin 6. Feel free to use your 3-dimensional space and just jump right over the top of my op amp. Now R2 is a 1K, and it goes from the inverting input to ground. So I locate my 1K, and I'm going to go from the inverting input down to ground. I've now built my amplifier. My input will come into the non-inverting input because this is a non-inverting amplifier. That's pin number 3, and my output's right there. Okay, now what I need to do is use the 100 kilo ohm potentiometer, just like we did in the lab where we looked at the beta for the transistor. So we're going to take a resistor. So I'm going to take a 1K if I can find one. Looks like 1K. And pad down my voltage before jumping over, or pad down my current actually, for jumping over so I don't accidentally burn this out. We're just doing the exact same thing we did there. We put this on. This is not on my schematic. I just describe it to you because you've done it before. And I didn't have a schematic for it, so I just went with this. Okay, now note, this needs to go down to ground. A reminder, if you have one of the handy boards like I do, you need these jumpers to get from this side of the board to the other. If you have one where that line's continuous, you won't need them. Also notice, because I moved my ground around, this jumper's up on the negative voltage. I want it down on ground. So I want this to go from positive to ground. I don't want a negative on this. And then I need a nice long wire out of the center to go back to the input. This is why I ended up moving the op amp over a little closer earlier, because I have a wire already cut for it that wouldn't have reached where at least wouldn't have reached easily. I'll put it right there. My last thing is I really need to measure the input voltage, and that's going to be hard because, well, I can't clip on anything here. So I'm just gonna slide this green one right in here into the non-inverting input. So I built my amplifier. This bit over here is strictly to go about testing it. So now if I go to the next page, I tell you to set Vin to 0.1 volts. You're going to measure V out. Gain is just output over input, so you just take this number, divide by this one. Make sure they're both in volts when you do this. Or they could both be in millivolts, so they have to be the same. That does mean your gain is going to be unitless, because you're going to take 1 divided by, you're going to take 1, if you take volts and divide by volts, you get no units. You'll just have a number left. That's gain. You put the gain amount inside log, take log of that, multiply by 20, and that's how you get gain in decibels. And you'll just do this calculation. You just need to learn to use this, because I know some of you actually talk decibels already. So this will help you start to match up what's going on. Alright, so I'm going to go down and just measure my input. So I'm going to set my multimeter here and hopefully not shut power off accidentally. Okay. Since you're not in front of the camera, I'd never set my multimeter there, but I don't have a lot of choice. Alright, so my input's supposed to be way down at 0.1 volts. So let's go down. There's 0, so we'll take it up. It's very jumpy down here, so you just got to play a little bit. Be a real light touch. In fact, at certain points, it's almost easier just to gently touch it in that direction without even grabbing it. That way you don't overturn it. This is the hardest. They get a little easier as you move further up. I'm probably going to call that good. 0.1 volts is 102.7 millivolts, and I measure the output. And my output is 1.142 volts, and I record all that as my output. Now I'm going to go down the table further, and I'm not going to go through and work the whole table. You can do that. I'm going to turn up. Let's go for a volt. So I'm up at 1.026 volts now. We'll call that 1 volt. And I measure my output. 11.36 volts. Now I will note there will be a time when you go up here, and if I measure my voltage high enough, top one I tell you is, well, I'll just go with this to make, this is beyond what I tell you, but your calculations are going to show that you should get a certain number for this 2 volts, and you're going to measure right here, and it's going to be way lower. I'll ask you to think about why. Well, your supply is 15 volts. So no matter how much my gain calculation says I'm supposed to get, I'm not going to get over about 14.5 volts because I just have a 15 volt power supply. So if I have calculations tell me I had to get 20 volts out, there's no way it's going to happen. So you've hit the rails. You would have distortion if you're putting something in because your output would not track with your input because you've hit the maximum power level. Alright, so we've completed our non-inverting op-amp for DC. Now when you get to AC, you'll want to come in and let's see if I can find my function generator. I'm not going to move the camera around for this. I'll come back and do it later. But I'm going to come in with my AC. Ground needs to go to ground like it always does. I'm going to get rid of my DC ground. I just want that. I'll leave it to the side but disconnect it, and I'll run my AC right into here. Then I will take my voltmeter, I'm sorry, not my voltmeter, my oscilloscope, and I'll hook it up for channel 1. This is just going to measure my input. And I'm going to set it the way I tell you to set it, which I believe is 100 millivolts RMS. Make sure to measure that on the oscilloscope. And then I'll take channel 2 and also get the output. And I can hook ground if I'd like to. It's shared inside my oscilloscope, so if I just make sure it's not connected to anything, I'll be okay. And make sure, again, these are all ground. Do not put them on the negative voltage. And now I should be able to, I'll turn it on, I'll track everything. I will have a sine wave going in at a certain voltage. I'll have a sine wave coming out that would be the amplification bigger. It should clearly demonstrate you have amplification. If it's a non-inverting op-amp, which this is, that means it should just directly match up the cycles. It'll just be bigger. So you want to look at those units and measure them and record what you have. I do tell you to put a capacitor in there. You've already got some around that will work. Just somewhere in the 1 to 10 microfarad range is plenty. Alright, so we're done with the non-inverting op-amp.